seniors, today we're going to start talking about linear and nonlinear relationships and what makes something linear and what makes it not. So let's go ahead and jump in. On your notes page, go ahead and draw your line. In the top left-hand corner, go ahead and write linear and nonlinear relationships. All right, so let's remind ourselves what a linear equation is. A linear equation are equations of straight lines. They must have a starting point, which is our y-intercept, and a slope that increases at a constant rate, continues to go up or down. All right, so if I want to determine, actually, if I'm just talking about a normal linear equation, I'm talking about something in the form y equals mx plus b. So if I wanted to do an example of that, if I had y equals 2x plus 1, this clearly has a starting point, has a slope of 2, it'll go up 2 and right 1 every single time. But not all equations are linear, and not all equations are going to look in this form. So if I want to determine if an equation is linear or nonlinear, I look for two things. I look for exponents in the equation. So if I had the equation y equals 2x squared, because of the exponent, it's nonlinear. The other thing I look for is variables in the denominator. So if I had a normal equation y equals 1/2 x plus 3, there is no variable in the denominator of this fraction. But if I had the equation y equals 1/x, there is a variable in this denominator. So this equation would be non-linear. Let's do an example. All right, example 1. Which is a linear function? I'm going to write these a little bit larger. This says y equals x squared plus 4. This is y equals 4x cubed. Y equals 1/2 x. And y equals 3/5x. Again, this is where I would have my notes out to make sure that I can eliminate answer choices. So again, I'm looking for exponents or variables in the denominator to determine if it's linear or nonlinear. Well, I see immediately that answer choice A, y equals x squared plus 4, has an exponent in it. So I know that this is not a linear function. Answer choice B, y equals 3/5x. Again, I see this variable in the denominator, so I know that it is nonlinear. Answer choice C, y equals 4x cubed. Again, I see my exponent, so I know that C is nonlinear. That leaves me with my last answer choice, which is D, y equals 1/2 x. And again, I know that this is linear because there are no exponents in the denominator. There are, no exponents in the equation, no variables in the denominator, and I know that this has a starting point of 0, and that this line will increase at a constant rate of 1/2. Pretty simple. All right, let's talk about coordinates as linear relationships. So, to determine whether coordinates represent a linear or nonlinear relationship, set the coordinates up as an xy table and find the slope between the points. If the table increases at the same constant rate, meaning the slope is the same, then it is a linear relationship or a linear equation. So let's go ahead and take these coordinate points. Go ahead and make sure that this is written down on your notes page. I'm going to set this up as an xy table. And again, if you're having trouble remembering which comes first, x or y, x always comes first in the alphabet, right? Well, same thing with graphing. So this will be my x side of my table, this will be my y side. And then I just plug these in. So I have -2, -3, 0, 5, 2, and 13, and then 3 and 17. And again, now all I want to do is find the slope of this table. And of course, the way that I do that is m equals change in y over change in x. So I'm going to find the difference between my y values and my x values. Y always goes on top, so we'll do that first. I'm going to pick my first 2 points, and I'm just going to find the difference between them. 5 minus -3 over 0 minus -2. Again, I just took points from my table and plugged them in. 5 minus -3 is going to keep change. It's going to leave me with 8. And then if I have 0 minus -2, keep change. That's going to leave me with 8 over 2. Make sure this is on your notes page. 8 over 2 simplifies down to 4. So I have a slope of 4. So what I need to figure out now is, does that work with this table? Well, the easiest way to do that is just to make a continuation of the table and plot every single point. So if I have my xy, and I have -2 and -3, if I were to plot my next point using the same slope, it would be -1, and then -3 plus 4 would just leave me with 1. And then again, 0 and 5. So you see how this is increasing by 4 every single time? Since it has a constant rate of 4 each time, I know that these set of coordinates are a linear relationship. And that's all you have to do. If the slope is the same each time, linear. If it's not, nonlinear. All right, guys, let's go ahead and jump right into practice. I'm super excited about this. I think you guys are going to do really well with it, so let's get to it.